Kia ora whanau, welcome to a Wānanga tutorial on angles and polygons. So this one here is one of the formulas that I suppose a lot of students probably just follow but not really fully understand, and that is this here, n minus 2 times 180, where n is equal to the number of sides that a polygon has, number of sides. So the sum of internal angles, internal meaning all the angles on the inside, sum meaning the total amount, that the internal angles of a polygon add up to is apparently equal to this, n minus 2 times 180 degrees. So let's take a look at this. A triangle. Fix. We know that this angle plus this angle plus this angle has to add up to 180 degrees. Yeah? We all know that. Some angles in a triangle equal 180 degrees. So, this triangle also is a polygon. Yeah? It is a three-sided polygon. Cool. Let's move on to this shape. So we know that angles in a triangle add up to 180. This is a square, a four-sided polygon. And what I would do for this is apply the formula. N minus 2 times 180 equals the sum of all the angles, all the internal angles. 90 degrees, 90 degrees, 90 degrees. So it should add up to 360 if the formula is correct. So we take the number of sides, which is 4 minus 2 times 180, yeah, which is 2 times 180, and 2 times 180 degrees is 360 degrees. And that makes sense because 90 plus 90 plus 90 plus 90 equals 360 degrees. So all the sum of internal angles of this polygon equal 360 degrees. Right, so how does the formula work? And it's because of this. It's because with these polygons, we can cut them up into triangles. Yeah, these regular polygons, so it's a triangle, here is a square. We can cut it up into triangles. Look at this. There's one triangle here, and there's one triangle here. What is the sum of all the angles in a triangle? It's 180 degrees. Well, we've got two of them. Yeah, look at that. We've got two lots of 180 degrees because we've got two triangles. If we add the two 180 degrees together, we're going to get 360. Oh, interesting. And look at this. We're going number of sides minus 2. Yeah, number of sides minus 2. And we got two triangles. Interesting. Yeah. Let's try the next one. So we're just trying to prove why this rule works. So apparently all the internal angles of this regular heptagon, five-sided polygon, this is a five-sided polygon, has to equal n minus 2 times 180. So let's try it. The number of sides is 5 minus 2 times 180. That's basically 3 times 180. And 3 times 180, if you plug it into the calculator, it will give you 540 degrees. So each of these corners added up together will give you 540 degrees. So how much is one corner? Well, you're going to go 540 divided by 5. 108. So each angle is 108 degrees. Just like the square, each angle was 90 degrees. Cool. Alright. And all of those 108 degrees added together will give you 540. So again, how did the rule work? Well, we divided up into triangles. Look at that. Here's another one. And that's the largest triangles we can find from here. We've got 3 triangles. And each triangle, the angles add up to 180. Here's another one, 180. Here's another one, 180. And look at the rule. We've got 3 lots of 180s. This is from that rule, n minus 2. And here we have 3 lots of 180s, which will actually give you 540 degrees. So it is right. So it's to do with the triangles, right? How many triangles you can make. If you want, have a go at the hexagon, 3-sided, 6-sided, sorry, 6-sided polygon, like that, and then like that. Oops. There you go. There. And have a go at this. Try and find the number of triangles, and then apply the rule. And the rule is n minus 2 times 180 to give you the sum of all the internal angles. Right? And I'll tell you right now. Oops. Terrible. Getting tired now. Here we go. 4 triangles. The rule is n minus 2 times 180. How many sides are there? Well, there's 1, 2, 3, 4, 5, 6 sides. 6 minus 2 times 180. 6 minus 2 is 4 times 180. And there you have it. Because you have 4 triangles. Yeah? And that's how the rule works for sum of internal angles of a polygon. Now, the second rule for angles in a polygon is actually the external angles of a polygon. So if we take, for instance, a triangle, apparently all the external angles equal to 360. So this is a 3-sided polygon. And all the external angles apparently add up to 360. Let's prove it. So I'll just extend these out. Just imagine this is an equilateral. This is a nice example. We've got 60 degrees here, 60 degrees here, 60 degrees here. Because it's an equilateral triangle, the sides are the same lengths, and so are the angles. And now, if we were to find the external angles, here they are. Yeah. This angle here will be 120 degrees. Angles on a straight line. That's obviously the same. That's going to be the same. If you go 3 lots of 120 degrees, these are all the external angles on the outside. It's 360 degrees. Yeah, so this is the other rule. External angles of a polygon equal 360 degrees. Let's try one more shape. Obviously, we'll increase the number of sides to 4, so we're dealing with a square. And apparently, this 4-sided polygon, the external angles has to equal 360. So let's prove that. Let's run this a little bit over, run that over, so we have some excess. Here we have 90 degrees, 90 degrees, 90 degrees, 90 degrees, and believe it or not, this side here has to be 90 degrees. External angles are colored in orange, and they're 90 degrees. So if we have 4 lots of 90 degrees, it's going to equal 360. Yeah. And you can actually experiment with the next shapes, the heptagon, 5-sided polygons, 6-sided polygons. As long as they're regular polygons, so a regular polygon, an irregular polygon will be something like this. It's like 4-sided, so think of this. Shit, that is a very bad example. An irregular four-sided polygon would be like this. Just move over to the right. Here we go. Would be something like this. Correct. That just turned into a triangle. Kind of like that. Well, that's an arrowhead, but yeah. Well, that's not like a regular four-sided polygon. Yeah. Again, a five-sided shape, you would look at a heptagon that looks like this. That's regular. And an irregular one could be 1, 2, 3, 4, 5. Regular, irregular. Cool. So yeah, these rules, you have to be careful. They work for regular polygons. Well, they do work for irregular ones too, but you have to be given extra bits of information. And just another thing to add before we leave, a polygon is always a closed-sided shape. Now we weren't dealing with any open shapes there, or open lines like parallel lines and stuff like that. They're all closed shapes. That's what polygons are. Cool. Hope this video helped, and we'll see you in the next one.